Alright, so today we're going to be talking about quadratic equations. Okay, so before you learn about quadratic equations, you've probably learned about linear equations. And we know that linear equations are straight lines, and as we can tell on this graph, quadratic equations, they aren't going to be straight, they're going to be curved. And there's some unique characteristics of quadratic equations, and we'll go over those with time. But first, let's just discuss what is a quadratic equation. What does that actually mean for us? Basically, in simple terms, a quadratic equation is anything that can be written as ax squared plus bx plus c equals 0, where a, b, and c are just, three different numbers, some sort of numbers. They can be positive, they can be negative, they can be fractions, whatever. And x, well, we know what x is. X is just going to be some coordinate here. Um, and usually this 0 won't actually be a 0, it'll be a y, and that will actually make it, make us be able to draw it here. And the only exception that we have here is that a cannot equal 0. Because if a equals 0, so if a equals 0, then we get, so this term is just going to cancel out because there's a 0. We're going to get bx plus c equals 0, and this looks awfully familiar to something like mx plus b equals 0. And by awfully familiar, I mean they're the exact same thing, except instead of the letter B and the letter C, we're using the letter M and the letter B. So if a is equal to 0, well then we don't have a quadratic equation anymore, we have a linear equation, and we would go back to what we know about linear equations. So that's what a quadratic equation is, to put it simply. Now, what is it, actually? What does it look like on a piece of graph paper? What does it mean for us? So a quadratic equation is any of these shapes that you see here, and they're also known as parabolas. Okay, so these are all known as parabolas. Okay, you spell that parabola, P-A-R-A-B-O-L-A, parabola. Okay, so all three of these are just known as parabolas. You can call them parabolas, you can call them quadratic equations, doesn't really matter. And there are certain characteristics about these quadratic equations. Let's go over some of them. Well, for some of them, you can see they kind of look like a smiley face, or maybe like a U. This one looks like a fairly skinny U, this one looks like a pretty big U, and others you can see they look like a sad face, or a frown, or maybe an upside down U or an N. And the way that we describe these different parabolas is we say that they're either opening upwards, or opening downwards, or open up, or open down. Basically, if it's open upwards, it's going to look like a U. So up, U. So we can see this black one, I would say it's open up or upwards. Okay? And we can also say the same thing for this blue one. This blue one is also open upwards. But what we can see for the red one is that it looks like a sad face. It's opening downwards. So open downwards. Okay, so that's the first thing, just describing our parabola. Is it opening upwards or is it opening downwards? Another thing that we can take a look at here is where is sort of the center of this parabola. And what I mean by the center is if I were to divide my parabola down some sort of vertical line, where would it be equal on both sides of the line? So for example, if I take a look at my black one, if I draw just a random vertical line right here, let's say, if I look to the right of it and to the left of it, they obviously aren't the same, right? The values on the right don't match the values on the left. So this wouldn't be that line. If I draw another one, maybe right here, this isn't the line either. I can sort of eyeball it in this case. I know exactly where that line is, but if you didn't know, there's a way to mathematically get that. And in this case, that line is right here. And we call this this line isn't actually there. We don't actually have to graph it, but this line, it does exist for certain. And we call this line the axis of symmetry. The axis of symmetry. And we call it the axis of symmetry because if we look at to the left and to the right of this axis, our graph is symmetrical on both sides. Okay, and we can get our axis of symmetry for this blue one as well. Again, there's mathematical ways to find this, and we'll go over those ways, but this blue line also has an axis of symmetry. Okay, it's right over here, axis of symmetry. And what we can actually do, let's do this red one as well. This red line, or this red parabola, the axis of symmetry is right here, and we'll label it as well, axis of symmetry. And what we can do is we can look at this axis of symmetry and ask ourselves, okay, well, where's this line? Well, in order to describe this line, it's just a vertical line at x equals 3. So I can describe this axis of symmetry with an equation, and that equation is x equals 3. I can do the same thing with the blue one. Okay, this axis of symmetry is at x equals -2. X equals -2. And with the black one, I can do the same thing. This axis of symmetry is just at x equals -1.5. Okay, so all these axes of symmetry, we can label them and write them down as an equation. Another thing that comes with the axis of symmetry is called the vertex. And what the vertex is basically it just means the maximum or the minimum amount that our parabola or our quadratic equation can reach. So what do I mean by that? Well, again, if we look at this black parabola, we can ask ourselves, what is the highest that this quadratic equation can achieve? What is the highest number? And we don't really have an answer for that because if we look at it, it goes upwards, and it goes upwards forever until infinity. As x increases, so is the y value. So we have really no upper value, and that goes for both sides. If we look at the left side here and the right side, it just keeps going forever. But if we ask ourselves what is the minimum, well, that's the lowest point that this parabola reaches. What is that point? Well, in that case, we can say that that point is right here. This is the vertex, or the minimum for this parabola. Okay, so we'll call that the vertex. And again, we can label the vertex. It is, after all, a point. Okay, in this case, what is the vertex? Well, if we look at the x value is -1.5. Okay, so that's where our axis of symmetry comes in, -1.5. And the y value is somewhere around -1.75. -1.75. Again, we're just kind of eyeballing it for now, but later on we'll be able to mathematically be able to find that value. And we can do the same thing with our other equations here. So in this case, the axis of symmetry is another minimum, or sorry, the vertex. This is another minimum point, because again, it goes up forever. So there's no maximum. The maximum is infinity. But there is a minimum point that it reaches. And that minimum, well, the x value is -2, and the y value is +1. So that is the point of our vertex. And finally, we can look at the red parabola here. And in this case, we don't have a minimum, we have a maximum, because this parabola opens downwards, okay? And it goes down to -infinity. But there is a maximum that it reaches, and that maximum is right here. And again, this is just the vertex. The vertex. And what is the point that this vertex is located at? It's located at +3, and the y value is 0. So that's the coordinates of our vertex. And now one more thing that I want to talk about here, and that's going to be our intercepts. Now if you remember with linear equations, we talked about the y-intercept, or where the graph crosses the y-axis. And we have that with parabolas as well. Again, if we look at the black one, we'll see that our black parabola crosses the y-axis at this point specifically. So this is our y-intercept. Okay, and I can label this y-intercept, and again, I can give it a point because after all, it is some sort of point on our graph. And that point, well, its x value is going to be 0 because it's the y-intercept, and the y value is going to be at -1. That is the y-intercept. But what we can also talk about is the x-intercept, and this is where our parabola crosses the x-axis. And in this case, for the black one, we have two places where that happens. It happens right here, and it happens here on the left. And these 2 points are known as the x-intercepts. X-intercept. And we have another one on this side. This is also the x-intercept. And again, we can label these points now. These points are a little bit more difficult to label, so maybe this one is something like 1.8, 0, and this other one on the left is maybe -3.8, 0, something along those lines. Again, we don't know exactly at this point, we're just kind of eyeballing it, but we will be able to find those mathematically eventually. Let's do the same thing for our other graphs. So we'll go to this blue one, and in this case, if we talk about the y-intercept, well, we don't see it here on the graph, but remember, these graphs go on forever. And so eventually, this blue graph will keep on going and going and going upwards here and to the right, and eventually it'll hit the y-axis. Okay, so there is some sort of y-intercept. It's just somewhere all the way up here, and we can't see it on this graph. But there is a way to calculate it, and there is a y-intercept. But if we talk about the x-intercept, what we'll notice is that it doesn't exist. If we ask ourselves, where does this parabola cross the x-axis? Well, it doesn't. It's above the x-axis, and it opens upwards. So therefore, it's never going to hit the x-axis. And so what we actually find is that there are no x-intercepts. Okay, well, let's go to the red graph and see what we get there. So on the red one, what we'll notice for the y-intercept, again, this graph goes downwards forever, and it'll keep going and going and going and going, and eventually it'll cross this y-axis somewhere in the negatives. Again, we don't know what that is, but we can calculate it. And if we talk about the x-intercept, well, there is an x-intercept. In this case, there's only one x-intercept, and it's this right here. Okay, so this is the x-intercept. Okay, and again, we can label the x-intercept. What is it? Well, it happens to be the same as the vertex, 3, 0. And we notice that there's only one. So with quadratic equations, we are always guaranteed to have a y-intercept. Our graph will always cross the y-axis at some point in time. However, for our x-intercepts, or where our quadratic equation crosses the x-axis, well, we have 3 different results for that. We can either have it cross twice, as we saw here with the black one. We can have it cross no times, as we see here with the blue one, or we can have it cross one time, as we see with the red one. So our x-intercepts are very unique. We can have 0, we can have 1, or we can have 2. Of course, we'll never have 3 or 4 or basically more than 2. So that's one unique thing about quadratic equations and parabolas. So that's kind of your introduction to quadratic equations and parabolas, what they are, a few terms that we use in them. So again, how does it open? Does it open up or down? Okay, remember upwards starts with a U, looks like a U. Downwards, sad face, you're always down. We talked about the axis of symmetry, or a vertical line that when we put it on our parabola, it will be completely symmetrical on both sides of that vertical line. And associated with that axis of symmetry is the vertex. Okay? And we also talked about our y-intercepts, so where the graph crosses the y-axis, and the x-intercepts, or where the graph crosses the x-axis. Okay? So that's everything for this video. Coming up in the next one, we're going to take a little bit more detailed look into parabolas and the quadratic equation, and we're going to analyze it a little bit more. So that's coming up in the next video.